Cool, today we're going to be writing a compiler/evaluator in PureScript. No worries, if you can read Haskell, you're going to be able to follow along easily. Of course, I chose a super silly example here. We have this language where we have two operators, which are add and sub. They just do addition and subtraction. And then we have integers. The trick in a compiler is to take pretty much a string and transform it into a data structure that can be easily manipulated. In this case, we will take this string and transform it into what is called an AST, or abstract syntax tree, that we can then work on. In particular, we want to go from that string to a data structure that looks more or less like what's shown here. And then with an AST like this, it's really easy to either translate this into a target language or evaluate this expression to a result. This will be the final result in code. So we start with a string, which is our input, and then we can do three things pretty much. One is that we can transform the string into the AST, as shown in the previous slide, or we can compile it to the target language. For example, we can imagine that this string here is the translation of our input into Haskell. Another thing we can do is that we can actually evaluate the expression right away, and we get the result too. Let's take a look at the data types. So we have our AST, which is nothing else than either a value, just an int, or an expression which has one operator and two ASTs. Then we have an implementation of show, and the other thing we need to implement is the operator, which in our case it's either an addition or a subtraction. Let's see how we transform the string into the AST. So with a parser combinator library from PureScript, we can define a parser that works as follows. It first skips all of the spaces, then it assumes the first thing to find is an operator. So we parse that operator, then we skip again all of the spaces. Then we know that an AST is either a value or a nested AST. So we try to parse a value. If that fails, we try to parse an AST. And this is recursive, of course. Then we skip spaces again, and we do the same for the second value on the string, and then we return whatever was parsed, which is, of course, an AST. Let's dig deeper. So parsing an operator means that we are looking for add or sub. These are the only two operators we have in our source language. So add succeeds when it finds the string add, and sub succeeds when it finds the string sub. Lastly, we have the value parser, which is just looking for an integer, and then it wraps it into our value constructor, which is of type AST. Int parser, which is defined here, is doing nothing else than collecting all of the digits found in the string and then trying to convert them into an integer. Okay, now that we have our AST, we can decide if we want to compile to the target language or if we want to evaluate the expression. Those implementations are super straightforward. So in case we want to generate the target language representation of our input, we take all the cases of AST, which means we either have a value, which in our target language is just the integer itself. If we have add, then we recursively generate the two sides of the add, adding plus and parentheses. And the same thing is done for sub, of course, using minus. Now, Evaluation is as simple. So here, if we have a value, we just take out the integer. If we have an add, we just sum the evaluation of the ASTs on both sides. And if we have a sub, of course, we just do minus. And that's it. That's our compiler. Of course, we're not doing any optimizations, and the source language is incredibly poor. But to me, it's awesome how with abstract data types and a parser combinator library, we can do things that are so powerful yet so readable. Great, so that's all for today. As always, I really appreciate all of the support you are giving me. That keeps me going, so keep it up. I'll see you next time.